Okay, so good morning and welcome to this webinar this morning, which is about IT and OT convergence and some of the challenges that are associated with that. So by way of introduction, my name is Andrew Beynon. I'm the Chief Solutions Architect for ARO, and I predominantly focus in the cloud, cyber and security space, and it's all things network related. A little bit of a mission statement there about myself. It's to provide the network solutions, but obviously make sure they're technically relevant to whatever that industry or vertical is. Looking at the ARO as an organization, so for a bit of history, we've been in operation for 25 years across the cloud, collaboration, data center and sustainability. Obviously 25 years is a long time and the cloud wasn't around there then, but as an organization, we span 10 offices across the UK, just over 400 employees, and look after somewhere in the region of 4,500 connected companies. ARO is effectively structured on 4 pillars, so cloud, collaboration, data center services and sustainability. And I tend to focus in the left-hand pillar there on the next generation networking, campus DC, large-scale indoor outdoors, or anything that's connected effectively falls into under my remit. Across the rest of the business, obviously, we've got these other elements from collaboration, lines, minutes, communications, right through to data center and hosted services, and obviously sustainability and helping clients achieve their net zero emissions. So if there's anything today that's in those other areas of interest, then please feel free to reach out also. I think no presentation is ever complete without a third marketing slide, and this one just shows some of our accreditations really and partnership statuses. We're an Aruba Gold partner, we're an Extreme Diamond partner, we're a Sonic Wall partner, a Fortinet partner, Microsoft partner, and so on. And we cover that whole plethora of services from cloud, from the cloud through to the connectivity, through the edge services, and so on. The purpose of today's webinar really is, as the opening introduction slide there said, was to try and help organizations manufacturing and obviously smarter, greener, more adaptable environments, but also trying to provide some insight and some, I suppose, some thought leadership in regards to some of those barriers that are preventing adoption or really driving the need to do so from a compliance perspective. So the challenges really with doing that effectively from an IT and OT networks are in partly because of dare I say a lack of understanding between different organizational structures where the IT, the traditional emails and information technology network is very different and very separated from an OT network, and the priorities for both of those two networks are different as well. So where we are quite accustomed to regular patch updates and having security updates forced upon us as part of an IT mandate, within the OT networks, they're typically more difficult to execute upon because any outages to the OT networks effectively cost money because they affect productivity. They have a different attack service as well because OT networks are typically or weren't typically designed to be connected to the internet, so that the likes of SCADA and PLCs and so forth weren't originally envisioned to be internet connected. And bridging those two networks has two different sets of skills. So plant engineering, automation engineering, and mechanical engineering is different from IT. And the challenges sometimes that bring those together means that if they're not correctly done, they can be a risk to either of those platforms from either of those systems. So what that really brings us on to then is the why do it and why not to do it. And I suppose what we're seeing in ARO with our clients and across the industry is as factories and production lines become more and more intelligent, there's more requirement for that information not just to be east-west within the particular IT environment or OT environment, but have the ability to take information out of the OT networks, out of the factory and out of the plant and provide that into the boardroom effectively. So now having north-south requirements for data transfer. The challenges for not doing it is any downtime to that OT network ultimately costs money. The reasons for doing it is obviously some of the regulatory compliance, some of the standards, some of those third-party supply chain agreements now need factories to have the ability to provide that information to the clients from a data-rich source perspective. And those environmental goals as well. How can we see what's going on within the factory and how can we then utilize that information within the IT networks? So I suppose just looking at the 6 points that are on the screen at the moment, the bottom three tend to be standard ISO accreditations through DORA, through particularly that's more from a finance and financial aspects, through to the NIS and NIS2 frameworks. They were there as models effectively to help us ensure we get that level of compliance. And then the upper ones, hopefully more familiar with the BSEN IEC, catchy name, 62443 effectively, which started as an international standard, then a European standard, then later British standards adopted, sets out a framework effectively across the top there, the same with the Purdue and NAMA models, for how that regulatory compliance and how those protections can be put in place and best achieved. So looking at 62443, for example, it splits the concept of it in the main is it splits into the concept of zones and conduits. Is how you compartmentalize the systems, either through policy procedures or components, into various security levels, and you adopt a risk-based approach for doing that. And the one that that jump out from there for me effectively are the ones up the top here, which have got the little light bulbs on it. Sorry, got the little light bulbs on them. The 413 effectively around the security of the conformance within the metrics of the system, the security life cycle and the use cases for doing it, and then how we implement those for asset management. But this concept of zones and conduits and this risk-based layered approach is a common practice that we're seeing. Is if you can separate your assets into particular groups and then decide what transport or what communication needs to happen between those groups, it goes some way to achieving the frameworks that were set out in 62443. The Purdue model is almost an extension of that, and whilst it's dissimilar in some areas, it provides us a clear separation between levels 0 and 2, which are the OT networks, and levels 3 and 4, which are the IT networks. And we're just in the middle there. It provides a natural basis really for where any segmentation between the upper and lower layers can be achieved, and how we can then make sure that the security that's applicable and the network connectivity that's applicable to the OT and networks can come together. The Beynon model is, I suppose, a bit more discrete in nature. It's quite niche. It's particularly was governed as a German automotive process effectively for doing that. But again, it breaks down the whole basis there between the concept of control systems and monitoring systems and optimization functions. So but the difference predominantly, this one being a newer standard, it was established with the IT and OT integration in mind, and how there would be a need for edge computing and open standards and cloud computing. And what that really means is if we take summary of those three effective policies or frameworks together, we've got Purdue bringing us the app segmentation, we got 62443 bringing in the security policies and role-based access controls, and then NEMA bringing in the how we can export that information and send that out to external systems. But what is applicable across all three of those effectively is this concept that security of converged networks is critical. And when we then look at some of the objections that we hear, that I come across in with some of my clients, is around why it won't work versus why it will work. And I think some of that predominantly leads to this one in the top right corner here. And again, apologetically, through this, I talked around the IT and OT convergence. I think it should be more of a phrase of more of a collaboration between those, because it shouldn't be driven from the IT into the OT networks or the OT into the IT networks. It should be that collaborative approach, how both of those respective parties can pull out the values for that. And that sometimes goes some way towards addressing the skills divide as well, making sure that there's a shared understanding of what the risk is, but also what the benefits are for those solutions. Typically, having an air-gapped system is a response I get to say, well, by having complete separation between the IT and the OT networks being air-gapped, both systems are actually safer. And whilst arguably that is true, I think it's fair to say by air-gapping them, there's obviously less visibility as well, because you're running two discrete systems as opposed to one uniform or unified solution there. So air-gapping true for improved security, but false when it comes to less visibility and the sharing of data there. The other challenge around it is the always-on processing versus the IT patching. So, as I said earlier, we've become quite accustomed to our Windows machines rebooting whenever happens to be, whatever that schedule is. But those luxuries don't exist within the manufacturing platforms, because we need to make sure they're always on, or always up, or always available. So we can't necessarily, and I'm not suggesting for 1 second that we enforce a policy of antivirus and patch management into those networks, but we need to make sure that if you are connecting them, that's a known risk, and that risk is mitigated in some other ways. One of the I suppose things that come out of that is some of the, as part of the research I've been doing, I looked at some of the things that the cybersecurity agencies have been saying, what the national cybersecurity in the UK has been saying, and so forth. And OT is the low-hanging fruit, and particularly that's in part because of those systems are not patched. They may have been in operation for 5, 6, 10 years, or whatever the period happens to have been, when the risk from cybersecurity was less. As more and more organizations have brought those risks together, those networks together, and they haven't been able to address some of those risks with things like, a couple of years ago, I don't know if anyone recalls, there was a Black Hat conference in Las Vegas where the Siemens PLCs, they were hacked with the monkeys effectively, and that led then to a complete change of the mentality around those and how they were coded. So there is definitely an increase in supply chain attacks. We've seen that more recently, the likes of Marks and Spencers, and whilst not manufacturing, so that the knock-on effect of the manufacturing to Marks and Spencers attacks is the impact that's had at supply chain and supply chain management through their organizations that they work with as well. So I think it's fair to say that these risks speak for themselves, and they're going to get more and more apparent as more and more of the networks become closer and closer together. The other consideration around those risks is something called island hopping, where a vendor or supplier or a third party who you interact with will be compromised. So if you've got support companies who have got palletizers, and their organizational packaging machines, or cold store freezers or plant, and they have a requirement to connect to your network to conduct support, it's making sure that they're not compromised, and when they connect to the network, they don't actually compromise your network through their own compromise as well, or vice versa. So in practice, some of the benefits for achieving IT and OT segmentation, but also that compliance and that coexistence, is by limiting the attacks, obviously on that, by having a method in place that prevents lateral movement within the networks, but also this concept that security in depth. And if we could secure the networks and allow easier communication within the networks, that's when we can leverage those benefits, and we can take the information from the plant, or provide information to the plant, or whatever's needed in line with that. So the risks, if done, or if not done correctly, financial loss, reputational damage, lost productivity, all of those type of things. But more importantly, things like theft of IP. If somebody compromises a manufacturing plant in a way that doesn't necessarily affect ransomware or some other component, but changes some of the metrics in the manufacturing, so there's a deviation in the manufacturing process that then causes a service to be degraded, and then return of those products and recalls. There's the impact as a result of that from reputational damage as well. So one of the ways that all of those those three frameworks call for separation is about dividing the networks effectively into those zones and conduits, or VLANs and VRFs. And if you're from an IT background, and the concepts of VLANs and VRFs has been with us for a long time. The two pictures on the screen there, if anyone recognizes them, are of Alcatraz, and microsegmentation as a knock-on effectively, this thing called macrosegmentation as well. And if you think of the US prison system as microsegmentation, you had prisons where each prison had cells, and each cell could be a portion to be a VLAN or a VRF or a segment of the network. And then you had Alcatraz, which was a prison within the prison system. So if you broke rules, you went to prison. If you broke prison rules, you went to Alcatraz. So you can have this concept of macro and micro segmentation, where you could have a segment which is all of the IT network, and a segment which is all of the OT network. But in each of those segments, we could break those down to whether it was finance and HR, or whether it was palletizers and packaging machines, or cold stores, or whatever it happened to be. And then we can use this concept of flows to control which traffic is in which micro or macro segment, and then we can apply policies to make sure the flows between those two traffic, so between cell 1 and cell 2, doesn't happen, and they can only access areas that are applicable to them. So what needs to be done for that to be achieved is where the challenge comes from, because to correctly understand your macro and micro segmentation, you need to map all of your IT and OT assets and then define a trust-based matrix that says these devices can talk to these devices, that can talk to these users on these devices and so forth. So the concept of that, building the zones, but then the conduits, which is the connectivity between those, can be achieved. And that could be from, as I touched upon earlier, whether that's secure remote management, whether you're doing patch accountability or patch management, and making sure then that each team understands, whether that's an IT team or an OT team, that the implications for doing that. And both NIST and DORA, which again, DORA being more financially industry regulated, ties into the ISO 27001 and 62443 to say that you should, once you've established those risks, you should test and test around the breaching of those. So from an Aruba perspective, as we started, so ARO are an Aruba Gold partner. We sit on the global ambassadorial group, and that means that one of the products that Aruba have is something called Aruba ClearPass. And Aruba ClearPass is a policy-driven engine for the enforcement of role-based access control, or you may have heard of it as AAA. And AAA effectively meaning for the authentication, the accounting, and the access elements of that. So if we can authenticate the device or the user onto the network, we can then establish what access that user needs or that device needs to the network, and then we can audit to see what's been happening, so we can ensure that regulatory compliance, and we can ensure that policy is then mapped to correctly to those devices. So as the example shows there, if a engineer plugs into a port, ClearPass checks the credentials of that user's device or the user or the machine that's plugged into, and then determines it can have the right access to the right VLANs, to the right VRFs only. And if it's non-compliant, it can be removed from the network. And we can take each element of that. So once we've authenticated the user or the device connecting, and we've determined what the access is for that user and that device should be granted, under the auditing element of that, we can feed that auditing information into the likes of firewalls or into other elements to force further segmentation or further controls within the network. And that could be if the engineer tries to connect to a device on the network, which is the wrong device, and the time of day doesn't allow it, or the time of day does allow it, or the location, we can have different policies for different devices. So a packaging engineer connects to a port may get a different response and a different security criteria that the electrical engineer would get. He connected his laptop to the device. If anyone has seen the film Kevin or Split, shall I say, they'll recognise who Kevin is. And this is really a crude analogy of explaining the different types of personas that networks have. So once, as part of those zones and conduits and bringing out identifying the personas within the network, we can classify those devices, and once we understand the classification, we can know which persona can relate to which other persona, and all the good ones can talk together and all the bad ones can talk together, or neither can talk to either. And this really was to try and illustrate those different split between those. But one of the challenges in understanding what flows are occurring within the network is visibility. And IT networks traditionally, whilst they'll provide you some information in regards to flows, that tends to be sampled information, where the network will take a ladle, effectively dip it into the switch fabric and say it pulled out so many packets of a particular type and said device 1 spoke to device 2 using protocol 1 talking to protocol 2 and so forth. The Aruba CX10K switches were originally designed for hyperscalers, so they sit quite far up the technical tree as far as Aruba concerned, but they effectively build in 800 gigs worth of stateful firewall into the switch fabric itself, meaning we can put a firewall, or the full firewall functionality, layers 4 through to 7, behind every port within the network, and we can tie them back to those personas. So taking that concept of conduits and zones and macro and micro segmentation, we can see all of the flows for all of the traffic, all of the time that's happening within the network, and then we can create enforcement policies based upon real-time observability rather than an assumed connection. So if you've got an application that starts up and starts talking to different devices, it may be because it's badly coded, or it may be because there's some malicious activity occurring within the network, and these switches effectively aim to stop that. That east-west spread of the microsegmentation level we talked around means by applying the firewall policy within the actual switches, there is no additional latency, and there is no additional need to hairpin traffic from an OT network through the IT network onto the firewalls, back through the IT network, back to the OT network. So we can make it more secure and quicker to respond, but above all, give it the functionality that we need to achieve that. So From a products and portfolio perspective, if we look at the the three effective frameworks that we've got there, from 62243 on the left through to the Aruba products that run across secure access, service edge, network access control, fabric. What I've tried to do on the next one is to show you some of those illustrations really of where those different products are needed and which type of products are applicable to which type of zones. So if you've got, you talk around the industrial zone effectively, and we look at what that means from an east-west segment perspective, or the likes of VXLAN, that means we can put any port on any part of the network and kind of ignore the underlying network transport. So if that means you've got a large disparate plant and you've got large disparate connectivity needs or macro and micro segmentations, we can use these technologies and use things like policy enforcement or ruggedized switching with dynamic segmentation to enable that connectivity to occur within the industrial zone. And similarly, then from a process control zone, we can do the same things with zero trust networking, policy on enforcement, even things like intrusion detection and intrusion prevention within the network. So what effectively that means is we can have full visibility, full control, and full compliance of all of the packets passing between both those networks from that collaborative response. And that's what I was trying to say earlier, is that I don't think it's feasible to apply the same level of security controls that we do to an IT network into an OT network without risk. And risk is obviously costs money, because when there's a lack of production or there's a problem with production as a result of those changes, it then becomes a barrier for further adoption to it. So this model advocates effectively a medium effectively, but that sits between both of those networks in a way to control it, provide the levels of security and the segmentation and the controls that you need, but not necessarily implement restrictive measures that would affect either side of those networks. So from a call to action effectively, what does that actually mean? So we, as touched upon earlier, you need to understand what those assets are, whether they're in IT, and from an OT, establish what those groups are from which ones should interact with each other, which ones shouldn't, and defining those groups and services, and then work out what your segmentation is in both the IT and the OT networks, because the network isn't just about transport any longer. So we've got some clients who are using the network for the adoption of smart sensors and IoT sensors within the manufacturing and within the plant factories. And what they're doing effectively, as an example, if you take a motor that's on a conveyor belt, it's got a CT clamp now fitted to that. That CT clamp is managing the amount of current or electrical draw that's going through it. The CT clamp then records a value as X under normal operation. It also has got a vibration sensor on there, or a heat sensor on there. And when the heat increases on that motor, or the vibration pattern changes from being an oscillation to to a fluctuation, and it sees an electrical draw up on there, it's indicating that it could be a problem with that motor or that bearing or that belt. And that's allowing those companies then to make proactive decisions as when to introduce the maintenance as a planned maintenance function, as opposed to a break fix because the motor seized or the bearing's broken or something. So the network itself now becomes not just the transport for the traditional networking, as in moving packets from source A to source B, or destination to source A to destination B, but also now as a way of leveraging things like humidity sensors, air quality sensors, vibration sensors, heat sensors, water sensors, leak sensors, and so forth. And some of these devices then sit on that network and they feed into the overall just-in-time or real-time manufacturing processes that are occurring within the plant. And similarly, using the network for things like asset tracking, asset management, where the warehouse stock control systems, where the wireless environment covers stock, but the fluctuations in component parts or in stock levels will go up and down, meaning the network has to respond to that because there's more concentration of users or devices, or there's more concentration of pallets, or there's a desire for barcoding and so forth within those environments as well. So the call to action really is, I would say, is if you can start with an assessment of your inventories, we can work out then what types of products or services, go back to that model from an Aruba perspective, that could be used to facilitate some of that, and help them, if necessary, with the design around those VLANs, those VRFs, to get that collaboration across the network. But I suppose as a flippant statement is, it's not about building smart factories for today, it's about making sure they're still there in the future. So unless we can apply those security models to it as well, it's all good and well having a really good productive factory. If it's insecure and it gets compromised, it's not a desired outcome that I don't think anyone wants anyway. So as a call to action, let's build those smarter and safer and more adaptable factories, but using the network to the best that we can. Thank you. Appreciate that was obviously quite a lot there, and quite quickly to get through. If anyone has got any questions, my email address was up in the beginning. I'm happy to answer those in person, or I can, we'll collate all of those and distribute those after the chat. But thank you, everyone.